Hopefully your class's results look something like this, where in flask 1, the balloon was the smallest. Flask 2 had the balloon get slowly bigger, and same for 3. And then once you got to 4, it was definitely bigger than 3. And 5 was maybe a little bit bigger than 4, but 4, 5, and 6 all look very similarly sized. And think about what we did in this lab. All groups used the same amount of vinegar, but varying amounts of baking soda. In flask 1, the baking soda was our limiting reactant. It ran out first. There should be extra acetic acid here. And then in 2, with a little bit more baking soda, the balloon got a little bit larger. And same for 3 and even 4. But once we get to 4, 5, and 6, we can start to see that it leveled out. And why that is because now there's going to be leftover baking soda and not enough vinegar. In fact, even in this picture, you can see here at the bottom that there's some baking soda left behind, meaning that vinegar was our limiting reactant and our baking soda was our excess. We could have really a flask number 7 where we added an entire box of baking soda, and the balloon shouldn't get any larger because our vinegar was our limiting reactant. So now, after you have your classmates take the balloon circumference of their balloon, you're then going to graph it. Make sure to give it a title and label your axes, and make sure it's a bar graph. Then, based off of the beginning of this video, you should be able to answer the analysis questions about which flasks had extra acid, which ones had extra baking soda, and which ones they were the limiting reactants.